All right, this will be our full-on review from everything we learned in the beginning of the semester until now, which is the factoring chapter. Okay, so number one, we have if x is equal to negative 3, y is equal to 2, and z is equal to negative 4, find the value of the expression 3x squared minus 2x plus 1 over 5y plus 2x. I'm sure this looks familiar, right? We spent a lot of time towards the beginning of the semester going over these, right? So this is all evaluate, right, by substitution. Remember, if a variable is equal to a negative number, you should put parentheses around it, especially for these squares, because that'll affect it, right? All right, so let me write this up here. We have 3 times x squared. So x is in parentheses squared minus 2 times negative 4 plus 1 over 5 times y plus 2 times x, right? And once we have this written down, we follow the order of operations. Remember, the fraction bar here is a grouping symbol. So that means everything, the numerator is one group that you would do first, and the denominator is a separate group. Okay, so I have in the numerator, I will do the exponent, right? 3 times negative 3 squared is positive 9. So this is 3 times 9. Then you have basically negative 2 times negative 4, right? Minus 2 times negative 4. That's your positive 8. So plus 8 plus 1, right? Let's just continue the numerator for now. That's 27 plus 8 plus 1, right? Which is equal to, what is that? 36, right? Okay, moving on to the denominator. We have 10 plus negative 6, which you can write as 10 minus 6, which is 4. And you have 36 over 4 is equal to 9. Okay, good. Let's solve each equation here. We have 7a minus 3 equals 6a plus 8. So this is a one variable linear equation. We bring the variables to one side and the non-variables to the other side, right? So let's subtract 6a on both sides. So if I subtract 6a here and over there, I get a minus 3 equals 8. And to solve for a, we need to add 3 to both sides, right? So we get a is equal to 11. Okay, number 3. 2/3 times x is equal to negative 22. So the coefficient is 2/3. So we can divide both sides by 2/3. Oh, why did I write negative there? It should have been positive 2/3. So now 2/3 over 2/3 is equal to 1x, right? And negative 22 divided by 2/3, right? We have negative 22 over 1 times the reciprocal, right? When you divide by a fraction, you multiply by its reciprocal. And I want to remind you, don't multiply first. You can always cancel out, reduce first, right? So this should be negative 11 over 1 over there, right? So you have negative 11 times 3 is negative 33 over 1, right? So you can say x is equal to negative 33, right? Anytime you multiply fractions, please try to cancel out first. That way you don't make the numbers larger, right? And then divide, which would be not productive. Okay, number 4. Solve for the indicated variable. This problem we need to solve for r, right? So I see that r is right over here. So we need to isolate r. That means get the term with r by itself. So we can begin by subtracting p on both sides. So we have a minus p is equal to prt. So we subtracted p, right? Remember these literal equations, right? So now I have r on the right side, but this is multiplied by p and t. So therefore, I can divide both sides by p and t. P and t. So the p cancels out to a 1, t cancels out to a 1. So the right hand side is just r, right? So your final answer should be a minus p over pt is equal to r. Right? That looks familiar? Okay. P equals 2L plus 2W. Now we need to solve for W, which is on the right hand side. So I need to subtract 2L on both sides. So I have P minus 2L is equal to 2W. Now lastly, I divide both sides by 2. So the 2's cancel out. So my final answer will be P minus 2L all over 2 is equal to W. Right? Now, since we just actually learned the factoring chapter, right? I want to point out a different way to do this, an alternative way to do this. You notice how on the right-hand side, there's a GCF of 2, right? So watch this. You can do P is equal to, let's factor out that 2 on the right-hand side. So we get L plus W. Right? So this is multiplication. So to get the L plus W by itself, we can divide both sides by 2. Right? So the 2's cancel out. We have P over 2 is equal to L plus W. How do you solve for W? You need to subtract L on both sides. So P over 2 minus L is equal to W. Now, I want you to check this out. Going back to this first solution. Remember how when we have a fraction like this, you can separate the two, right? It's not necessary, but if you wanted to separate the two into two separate terms, you have each numerator divided by the denominator, right? Minus 2L over 2, right? And what happens here? The 2's cancel out. So you got P over 2 minus L, which is the same solution over here, right? So either way you do it will be correct. All right, any questions so far? All right. Okay, let's do this one up here, number 6. Okay, number 6. 2x minus L. So this is inequality, right? So it's a less than symbol. 5 plus 4x. So we have to bring, it's a linear inequality. So we need to bring the x's to one side and the non-x's to the other side. So let's just bring the x's to the left-hand side. Let's subtract 4x on both sides. So we have 2x minus 4x is negative 2x minus 7 is less than 5. Then I want to isolate the x, so I add 7 to both sides, right? So I get negative 2x is less than, we plus 7, right? Add 7 to both sides, we get 12, right? Now here's the thing that everyone should not forget. When you have to divide by a negative 2 on both sides of an inequality, or multiply by a negative, the inequality sign needs to flip, right? Change. So we have x is greater than 12 over negative 2 is negative 6. Okay, so that was a very important step. Now, if we wanted to write this on a number line, we have, let's say, we know where the numbers are, right? I'll just write negative 6 here. So x is greater than, that means that would be an open circle at 6, right? Because it's not including 6, and it's greater than negative 6. So you shade to the right. So x represents all values that are greater than negative 6. Okay? Any questions with that? All right, let's try the next one. The next one I will do in green. So I notice in this problem we have to distribute first, right? So this right hand side should be 7x. Distribute the negative 3. So we have negative 3x, and then negative 3 times negative 1 is plus 3, right? People tend to forget to distribute it into every term in those parentheses. So now I can combine like terms. So this right hand side should be 7x minus 3x is 4x plus 3 is less than or equal to, right? So 2x minus 9 is less than or equal to 4x plus 3. So now I can bring the 4x over to the left hand side. So subtract 4x. So we have negative 2x minus 9 is less than or equal to 3. To isolate the x, we add 9 to both sides, right? So we have negative 2x is less than or equal to 9 plus 3, or 3 plus 9 is 12. And lastly, we divide both sides, right, by negative 2. And when you do that, the inequality needs to change. Less than or equal to becomes greater than or equal to negative 6. Oh, look at that, very similar answers. So now I'm going to graph this on the number line. Here is negative 6. So because it's greater than or equal to, that means it's a closed circle, right? Greater than or equal to. And then you shade to the right. So x represents all numbers that are greater than or equal to negative 6. Any questions so far? Doing okay? So of these problems, do they look pretty familiar? Do you think you can do them by yourselves? This is kind of like a good review for the final. In the system of equations, we have two or more equations that are similar, right? And since this is a two-variable linear equation, the graph of this, each of these are lines, right? And lines tend to intersect, and wherever that point of intersection is the solution to the system. All right, so that was a brief summary of what a system is and what it I hope you could visualize that. Now we learned two methods to solve the system, right? The first one was we can not isolate. You can make one of the variables opposite terms, right? If this is 3x, you can make this negative 3x. Or since this is negative 5y, you can make this positive 5y. So you multiply all the terms by that number. So when you add them, that term, that variable will cancel out to a 0. So let's go ahead and cancel out the x's, right? So if I wanted to cancel out the x, the second equation I need to multiply by a 3, right? If I multiply this by a 3, so technically I won't be lazy. I'm going to write times 3 to both sides, like that. So I have negative 3x plus 3y is equal to negative 3. And the first equation remains the same, right? 3x minus 5y is equal to 5, right? The point of doing that was to create opposite coefficients. So when we add vertically, right, 3x minus 3x is 0. Negative 5y plus 3y gives me negative 2y is equal to 5 minus 3 is 2. So I have one variable equation. I can divide both sides by -2 and solve for y. So y is equal to -1. So we're not done yet. We need to solve for both variables. So I can substitute it. I'm going to choose the second equation, right? -x plus y is equal to -1. Right? So I'm going to add 1 to both sides. So I have -x is equal to 0. I'm trying to solve for positive x. So the last step, even though I don't want to be lazy here, right? So we get positive x is equal to 0 divided by -1 is still 0. So we have x is 0, y equals -1. This is, remember, it's an ordered pair. So I'm going to write the x coordinate first, comma, the y coordinate. And that is our solution. Okay? Does this look familiar? Okay, so the second system of equations is set up so that substitution is a little bit easier. So let's go ahead and do it that way. So I have 2x minus 3y equals 13, but the second equation is x is equal to 3y plus 9. So what I can do is, instead of doing the other way, I can take this is x, right, and just substitute it in there as a quantity. So this will become 2 times x, which is now 3y plus 9, minus 3y is equal to 13. Right? Everyone see that? Okay, so now I can distribute. So 2 times 3y is 6y, 2 times 9 is 18, minus 3y is equal to 13. Combine the like terms. 6y minus 3y is 3y plus 18 equals 13. To isolate x, I need to subtract 18 on both sides. So 3y is equal to 13 minus 18 gives me -6. Oh, nope, I'm sorry. I cannot add or subtract. It's -5. And lastly, we divide both sides by 3. Y is equal to -5 over 3. So don't stop there. We're not done. We solved for one of the variables. We need to solve for the other. So the second equation is where I can substitute it, right? Because it already says x is equal to. So I'm going to substitute it into this second equation, right? So x is equal to 3 times 3 over 1 times -5/3 plus 9. And like I said before, when you multiply fractions, look to cancel out whenever possible. It's easier, right? So I have -5 plus 9 is equal to 4. Right? So we have our x coordinate, our y coordinate. Therefore, it's an ordered pair of 4, comma, -5 over 3. So this is the coordinate. This is the ordered pair where these two lines will intersect right at that point. Find the slope and y-intercept of the line represented by the equation. So right now, 2x plus 5y equals 10. That's in our standard form. Let me write that over here, right? That's our ax plus by equals c. And I want to find the slope and y-intercept. That means I have to somehow manipulate this equation so that it looks like y equals, right? We have to solve for y equals, and we'll have slope-intercept form, right? If you recall, this is our slope-intercept form, and m is our slope, and our y-intercept is b, right? So if you were writing it as ordered pair, it'd be 0, comma, b. Alright, so let's solve for y here. I need to subtract 2x on both sides. So I have 5y is equal to negative 2x plus 10. Then we divide both sides by 5 to solve for y. So I have y is equal to, so now I need to create this as two separate terms. And if I want to do that, I basically have to divide each numerator by the denominator, right? So I have negative 2 over 5x plus 10 over 5, which is 2, right? Okay. Now we have it in slope-intercept form. What is our slope? Our slope is the coefficient of the x term, right? So m is equal to negative 2 over 5. What is our b? It's plus 2, positive 2. So our b equals 2. So our y-intercept is 0, 2. Or you could just say 2 as well. It's implied. Any questions there? Okay, then let's move on. And this time we're going to find the equation of the line that satisfies these conditions. So this one, you're going to notice that you have two ordered pairs, 2 points. So first we need to have the slope. And when you have this 2 ordered pairs, I'm going to label this x1, y1, and this one as x2, y2. So the slope formula is it's basically delta y over delta x, meaning the change in y. So we find the difference of the y's, y2 minus y1 over x2 minus x1, right? Without the slope, we don't have an equation. So let's do that first. We have 7 minus 1 over 1 minus a negative number, negative 2. Right? Don't forget to put in that negative. So 7 minus 1 is 6. 1 minus negative 2, this is 1 plus 2, gives me positive 3, which is 2. Right? So our slope is equal to 2. Now that we have our slope, we have one of the points, we can plug it in to either one of our line equations, right? So I'm sure most people prefer the slope-intercept form, but I do still want to point out the point-slope form, right? Which is y minus y1 is equal to m times x minus x1. So when you have a slope and 1 point, you could throw it into that equation. But if you are still more comfortable with that, we can do that as well. Okay? So for the sake of the video, I'll do both ways. The first one is the point slope form. So I'll use this first one here. Okay, so y minus y1 is equal to m times the quantity x minus x1, just like that. So this is x plus 2, right? So I have y minus 1 is equal to, I have to distribute this 2. So I have 2x, 2 times 2 is 4, right? So if I wanted to convert this, I would, into slope-intercept form, I would just add the 1, right? So I have y is equal to 2x plus 5. So that was the first way. Hopefully that looks very familiar. Let's do it the second way, which is using the slope-intercept formula. So I'll use one of these. Let's do the first one again. So y, this time I have to plug in this y equals 1. And m is 2 times x. X here, x1 is negative 2 plus b. So we do this so that we can solve for the y-intercept b. So I have 1 is equal to negative 4 plus b. Now I have to solve for b. We add 4 to both sides, so 5 is equal to b. So now I can say the equation of the line is y equals mx plus b, which is the same as the other way. Okay, so how does that look? Does this look familiar? This is probably one of the final exam questions, so prepare to answer this one. The next question here is usually not a final exam question, but it is tested in most other schools. So let's do it. Now the key word here I'm going to point out is, all right, let's read the problem first. The line L has y-intercept 0, negative 2, and is parallel to the line with the equation 3x plus y equals 5. Now remember, y-intercept 0, negative 2. That means our negative 2 is our b, right? B equals negative 2. And then the other key word here is parallel to this equation, right? So to find the equation of any line, you need a point and you need the slope. So it's parallel to this line. I need to find the slope of this line first. So what I'll do is subtract 3x on both sides. So y is equal to negative 3x plus 5. So now I can see the slope of this line is equal to negative 3. Parallel means they have the same slope, right? So I can use negative 3 as my slope and then create the equation of the line. So y is equal to negative 3x minus 2, because y equals mx plus b, right? We have b, we have m, so that's the equation of the line. Very simple, I hope. Okay, so simplify the results. That just means combine the like terms. So I see my first pair of like terms is right there, right? They have the same variables with the same powers, right? X squared, y to the first, y to the first. So I can just subtract or add the coefficient. 7 minus 5 is 2. So I get 2x squared y. And then the second pair is 3xy and 2xy. So I can add those and I get 5xy. Easy peasy, right? Next one, we have this group here in parentheses and over there. So first thing we need to do is distribute any negatives before the parentheses. But this is all positive, right? So you're just distributing a positive one. So all the terms remain the same. So let's remove these parentheses. Negative 3x squared plus 5x minus 6 plus 2x squared minus 3x plus 5. Now I look for the like terms. So I see negative 3x squared plus 2x squared is negative x squared, right? So actually, let me use a different color here. Use a different color. Hold on. Just so it's not confusing, I'm going to cancel these out. That shows I did them. Negative x squared. Then I have positive 5x minus 3x. So that's positive 2x. And then lastly, negative 6 plus 5. So that's negative 1. So that's our final answer. Any questions with that? All right, so I can see that number 15, we have more parentheses. This one, when we distribute to 1, this remains unchanged. 5x squared plus 4x minus 3. But over here, we have a minus sign here, this negative that we need to distribute. So this becomes negative 4x squared plus 5x plus 1. So now we can combine like terms. 5x squared minus 4x squared, right? So that's just x squared. We have positive 4x and 5x gives me 9x. Negative 3 plus 1 is negative 2. And that's our final answer. 16. This looks like distributive property. So 3x times x squared is 3x to the third. Remember the product rule of exponents, right? When you multiply x to the first times x squared, you add the 1 and the 2, so that's why it's x to the third. Then you have 3x times negative 2x, so that's negative 6x squared, right? 1 plus 1 is squared. Lastly, 3x times 2 is just 6x. All right, number 17 is, this is all from 16 through 18. These are all from chapter 5, right? So this is the binomial times another binomial. So this is our foiling that we covered not too long ago, right? So let's do that. We have 2x times x gives me 2x squared. 2x times 1 gives me positive 2x, right? Plus 2x. Then negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. Then we have to remember to combine like terms. So our final answer should be 2x squared minus 3x minus 5. Right? 18, this is distributive property again. You got to do it for more terms this time, right? So x times x squared is x cubed. X times negative 3x is negative 3x squared. And the last term is 9x. So that takes care of the distribution for x. Then we have to distribute this positive 3, right? So plus 3x squared, right? Plus 3x squared. Then you have minus 9x, right? And then plus 27. So let's combine like terms. The highest to lowest, right? Exponents, the powers. So x cubed is first. There's no other x cubed. Minus 3x squared plus 3x squared. That gives me 0x squared. So I don't have to write anything there. I have 9x minus 9x is actually 0 again. So as you can see, these cancel out to 0. So I'm left with plus 27 at the end. There's another foiling problem. So we have 4x times 2x, I'll write it up here, is 8x squared. 4x times 5 is 20x. Negative 3 times 2x is negative 6x. Negative 3 times 5 is negative 15. Combine like terms. So we have 8x squared, and then 20x minus 6x is plus 14x minus 15. Number 20. Remember, this is our difference of squares, right? Does anyone remember what this answer would be? So I'll write it over here. If you have something basic like this, x plus y times x minus y, right? It's just the first squared minus the second squared, right? Because the two middle terms cancel out, right? So if you didn't know that and you just distributed, it's okay. You still get the same answer. I'll show you. A times a is a squared, and then this would be plus 3ab. This is minus 3ab. And lastly, this is minus 3b times 3b is 9b squared. So as you can see, these two middle terms cancel out. So you're left with a squared minus 9b squared, right? So if you had done the difference of squares, method, right? This would be a times a is a squared minus 3b times 3b, or 3b quantity squared, which is just a squared minus 9b squared, right? Okay, let's move on to 21. 21 is a binomial squared. So if you recall, if you don't remember what this means, you could just expand it and then FOIL that way, right? But I do want to remind you about the binomial squared formula, which would be over here. Binomial squared. So if you have, I'll use a plus b squared, right? This is always equal to a squared plus 2 times a times b plus b squared. Or if you had a minus b squared, this is a squared minus 2ab plus b squared. So going back to this, to number 21, if you didn't know that and you just FOILed, you would get x squared minus 2xy minus 2xy plus 4y squared. And then you combine the two like terms, you get x squared minus 4xy plus 4y squared. So that would be the old-fashioned way. If you knew this formula, you can do it the other way. So this is what I mean by that. So let's say we had x minus 2y squared. So you see the first term is a squared. So that's just x squared, right? So since this is a minus 2y, I'm going to put minus 2 times x times y. Y here, I'm sorry, 2 times a times b. So y, it's actually 2y, right? 2 times 2y. And then plus b squared, which is our 2y squared. So I know this looks complicated for now, but when you practice this, you'll end up being able to do these in your head. X squared, and this is what? Minus 4xy plus 4y squared, which is the same solution doing it the foiling method. Okay, so number 22, I see that I have 3 factors I need to multiply. But the reason why this is not that bad is the second pair is actually a difference of squares, right? You see how this is a difference of squares, which we just covered in number 20, right? So I'm going to do that first. So 5x times 5x. So 5x squared minus, I'm going to do the formula for this one, 3y squared, right? So that's 25x squared minus 9y squared. So I have this product times the 2x that we can't forget about. I'll just multiply it, distribute that, and I get 25 times 2 is 50, and I have x cubed minus 18xy squared. So that actually looked complicated, but it was not. All right, we are almost there. Let's keep going. Use the properties of exponents to simplify each expression. So I hope you remember the laws of exponents that we covered. It was probably a little while ago. All right, so this is in chapter 5. Negative 2x to the negative 2y to the third. All of this is raised to the third power. So this is our power rule of exponents, right? In our power rule, we have, let me zoom in a little more. If you remember really briefly, right, a squared, actually, let me not use, let me do this. So let's say you had x to the a, raise this all to the b power, and you multiply, right? You get x to the a times b. That's the power rule of exponents. So you have over here negative 2 to the third, x to the negative 2 times 3, right? I'll just write it like this so people can see where it comes from. And then y to the 3 times 3, right? So negative 2 to the third power is still negative 8. And then x to the negative 6, y to the 9. Do you all agree with that? We can't leave exponents as a negative number, so we need to make this positive, bring it down to the denominator. So negative 8, y to the 9th over x to the 6th power. So hopefully you can brush up on these. They're not too bad. Next is our number 24 when we divide, right? This is our quotient rule. So if I have x to the a over x to the b, that's simply x to the a minus b, the difference of the exponents. Right? 27 over 9, that's just 3. Right? A to the 5th over a, that's a to the 5 minus 1. And we have b to the 7 minus 1. So that's just 3, a to the 4th, b to the 6th. Hopefully that was pretty easy. Number 25, it's power rule and then product rule. So let's do this first one because there's a power rule, negative 2, that's affecting this first term, or the first group here. So this is 2 to the negative 2, right? X to the 3 times negative 2, y to the negative 2 times negative 2, right? So I'm just doing that first one. So what is 2 to the negative 2? That means we have to make this a positive exponent, right? Before I do that, let me just write this again. 2 to the negative 2, x to the 3 times negative 2 is negative 6, y to the positive 4. So I'm going to finish this first group. These all go to the denominator. The only thing in the numerator is y to the 4th. And then you have 2 to the second power. Let's change it to a positive, and x to the positive 6, right? And that basically becomes y to the 4th over 4x to the 6th. So that's this first one right here. I'll do the second one in a different color. Now this is just 1 over x to the 3rd, y to the 1st. So we need to multiply the first one by this second one. So multiply over here by 1 over x cubed y. And what do we get? Let's combine it first so we can see what happens. So I have 4x to the 6, x to the 3rd, y, right? So easy way to do this is just anything in the denominator that's being multiplied, you can add the numerators, right? And then this is our quotient rule. So we have y to the 4 minus 1 is y to the 3rd over 4x to the 9th. That's our final answer. Okay, any questions there? Okay, then let's move on. 26. We have no exponent power rule over here, so we can just start doing the quotient rule. So we got 16 over 8. There are multiple ways to do this, but 16 over 8, we have, that's 2 in the numerator, right? X squared over x to the negative 1. So you could write that as x to the 2 minus negative 1. Y to the negative 3 minus 2, z to the negative 4 minus negative 5. So let's see what that comes out to. That's 2x to the 2 plus 1 is 3. Y to the negative 3 minus 2 is negative 5. Z to the negative 4 plus 5 is positive 1, right? So the only thing that needs to change is this negative exponent. So we have 2x cubed z over y to the positive 5. Any questions? All right, then let's move on. We're almost towards the end. Okay, this is going back to what we learned this chapter in 6, right? Chapter 6. Let's do these pretty quickly. We have factor each expression. We have 12x plus 20. So look for the GCF, right? The GCF of 12 and 20 is what? 4, right? So let's factor 4 out. We have 3x plus 5, right? And that's it. 28. Just because we did a chapter 5 review just now, we can see this is our difference of squares, right? If you forgot, it's a squared minus b squared equals a plus b times a minus b. So as you can see here, this is 5x squared minus 7y squared, right? So this factors into 5x plus 7y times 5x minus 7y. Difference of squares is pretty common. Make sure you identify them. 29 is factor by grouping, right? Because we have 4 terms, so I look for the GCF of the first group. 12 and 15, that's what? 3, right? And then the x. So we have 3x times 4x minus 5. Right? In the second group, this is positive, so we could take out a 2, and we get 4x minus 5. We have the common binomial factor, 4x minus 5, times the remaining factor is 3x plus 2, and we're done. Right? Okay, number 30. So I look for GCF first. There is none. So then I see that the a is greater than 1. So we can multiply a factor by using the AC method. Let's do a times c is equal to 2 times 15 equals 30, but b is equal to negative 13. So if AC is 30 positive, right, and b is negative, that means both of these factors must be negative. So I can see that negative 3 times negative 10 equals positive 30, and the sum is equal to negative 13. Right? So I rewrite the middle term. So 2x squared minus 3x minus 10x plus 15, and then we factor by grouping. Right? The first group, GCF, is x. And you have 2x minus 3. The second group, this is a leading coefficient that's negative, so we should factor out a negative 5, and we get 2x minus 3. The common binomial factor is 2x minus 3, and the other factor is x minus 5. Okay. And the last page. We have to solve the quadratic equations, which is pretty much what we just did for homework or this past Monday. Oh. Okay. X squared plus 2x equals 15. We need to set it equal to 0. So this should first say x squared plus 2x minus 15 equals 0. A is equal to 1, so I just need to find factors of negative 15 that add up to 2. So I see that the larger factor needs to be positive, so 3 is negative and 5 is positive. That gives me 2, right? So that's just x minus 3, x plus 5 equals 0. Set each factor equal to 0 using our 0 factor rule and solve for x. So x is equal to positive 3 or x is equal to negative 5. 2 solutions. Number 32. Notice this is a difference of squares, right? X squared minus 3 squared. So when I factor this, it's just x plus 3 times x minus 3 equals 0. Set each factor equal to 0 and solve for x. So x is equal to negative 3 here, or x is equal to positive 3. And when it's negative 3, positive 3, we can write it as x is equal to the plus or minus symbol, meaning both positive and negative 3. Okay. Last problem for today is polynomial divided by a monomial, right? So in this case, it's just dividing every term in the numerator by the denominator. So we have 24x squared y to the 5th divided by 3xy. So that gives me 8, right? Here, maybe it'll help if I write out what each term is. This is 24x squared y to the 5th over 3xy, and then minus 15x to the 4th y squared over 3xy plus 9xy over 3xy. So hopefully that'll help you understand what we're doing here. 24 over 3 is 8. This is x, y to the 4th. Second term is minus 15 over 3 is 5, x to the 3rd, y. And the last term is plus 3, right? The xy cancels to a 1. And we get xy to the 4th minus 5x cubed y plus 3.